All right, so I got to here and the video cut off, but you can see, and I didn't notice, I take that bottom fraction, multiply by the reciprocal, and then these guys cancel. You're left with 1 over AB, which is letter C. All right, here's another problem that says solve. So we got x equals, so I'm going to rewrite that. I'm going to go ahead and factor this. So basically, okay, you caught me in thought. I looked at that to factor it just because it's an instinct, but that's really not what they want. It's not factorable. So what they really want, just sticking with the program, is get rid of that denominator. So I'm going to multiply by 2x plus 8, so they cancel. But then I got to multiply this side by 2x plus 8, distribute. So I get 2x squared plus 8x. Look how nice this thing cleans itself up. 2x squared plus x minus 7. These will cancel. Subtract x, so I get 7x equals negative 7. So divide by 7, x is negative 1. Number 20. Hold on one second. Scratch that. Number 16. So I saw that number 20 also had vertical and horizontal asymptotes. So I got a little confused, but we're just going to attack number 16 and see what happens. So here's your golden rules for horizontal asymptotes. Now it might be confusing with all the wording, but I'm going to go through it. Top degree less than bottom degree. Notice that's a 1, that's a 3. That means your asymptote will always be y equals 0. You can type it into decimals if you don't believe it. What happens when the top degree, the 3, equals the bottom degree, 3? Then you take the coefficients of these two items, you ignore the others, take these off, and miraculously 1/3 will be your horizontal asymptote. Third possibility, if the top degree is greater than the bottom degree, like it's so, 3 and a 1, there's never an asymptote. So with that in mind, let's do the easy part first. And, well, it's not so easy. The vertical asymptotes we're going to get from our domain in the bottom. So let's take a look at this. X to the 4th plus 2x squared minus 3 equals 0. So we're trying to find out what x cannot be. So I'm going to slide this up. And we notice that this is just a trinomial. Yeah, it's a weird looking one. But this is going to be x squared and x squared. 2 factors of negative 3 that add up to 2. That would be plus 3 and minus 1. Now this guy is going to feed me a lot of information, because if I go x squared minus 1 equals 0, one student would just see that that's a difference of 2 squares and go x minus 1, x plus 1 equals 0. And then they would say x equals 1 or x equals negative 1, which means x can't equal those things because those would create zeros in my denominator. The other student would just take the 1 over and get this and go bada boom, bada bing, do the right thing. You got to remember to do that. X equals plus or minus 1, but this is what x cannot equal. Okay, now if I look at this one, and I do the same thing, and I subtract 3, if I set this equal to 0, first of all, it's not factorable. If I take the 3 over, and then I go bada boom, bada bing, do the right thing, you can see these are imaginary numbers, and you're not going to have imaginary numbers anywhere on your xy axis, so these are not going to be your vertical asymptotes. These are x equals 1, x equals negative 1 are your vertical asymptotes. Now, if you're on a multiple choice test and you know this, you could just go to your answers and see that x cannot equal plus or minus 1 is your vertical asymptote. You could play process of elimination and just go, aha, it's got to be A because that's the only one. But let's take a look at this horizontal asymptote and look at our rule. Remember our rule? If the degree in the top equals the degree in the bottom, you take the coefficients of those two equal degree terms. So there's a 1 there and a 1 there, and you ignore everything else. y equals 1. 1 over 1 would equal 1. So that double confirms our suspicions. All right, your classic faucet problems. There's some general things you just kind of have to lock in. So here we go. The original formula is the amount, like for this particular problem, like if we only had one pipe or one faucet, the amount would be the rate that it's flowing times the time that it flows. But we're going to manipulate that because these problems, I'm going to use a fancy word, are conducive to us thinking this way. And you're going to see why. So we divide both sides by time. We get rate equals the amount divided by time. So what we're going to say is, and another review, you can combine your rates. You cannot combine your times. We mentioned that in an earlier problem. But you can combine your rates. So while faucet A is pouring, we can add it to faucet B to see what kind of amounts are being added together. Like how much do they get done together? So here's the thought process. Faucet A, it says it takes 4 hours to fill a tank. So it gets it full, the amount, it fills it up, it's completely full, that's what a 1 represents, but it takes 4 hours. And then faucet B, it says right here it takes 6 hours. So to fill it, it would take 6 hours. Now, what we're going to look at is if they actually are filling the whole, a tank together, and we added this together, this would be the same thing as 6/24 plus 4/24. And so what we say is that would add up to 10/24, which I'm going to reduce that to 5/12. So what that's saying is, and this is a little bit of a confusing moment, but what it's saying is, as they work together, as these two faucets are pouring in this tank together, they will fill a tank up 5/12 of the way in 1 hour. So it asks, how many hours will it take the two faucets to fill the tank together? Well, once we've concluded they fill up the tank 5/12 of the way in 1 hour, I'm going to take 5/12, which is 1 hour, add it to another hour work, and I think, okay, in order to fill the tank, right now I have 10/12 in 2 hours. I know I'm not done yet, so I still need to add, here comes a little tricky part, 2/12. Now the tricky part here is to think in terms of time. So as I can see, these two working together in 1 hour fill up 5/12. So basically what I'm going to say is, I'm going to turn this into a ratio. 5/12 in 1 hour equals 2/12 in I don't know. And then we're going to just use that ratio and multiply. 5x equals 2. I'm going to divide by 5. X is 2/5, which is 0.4 of an hour. So I'm going to multiply that by 60, which is going to be 24 minutes. And let's see, the actual answer here, we know it's 2 hours. I thought they wanted hours and minutes, but they want it in terms of hours. So it's 2 hours plus 4/10 of an hour, which is 2.4 hours. So that's tricky. Which is letter B. There it is. Looking for translation, truths. So now it says the graph of xy equals 6. So here's xy equals 6. If we just divide both sides by x, we can kind of see a variation of the parent function here. Because that's what they did in these answers, especially the first one. It says translated 2 units up. So we can see that if this is our parent function and we add 2, That's like, yep, that's going to move it up 2, and that's going to move it left 2. So they give us a straightforward one right away. Now the rest of them are a little trickier. So if we investigate letter B, and we take a look at this, we're going to move this around. I'm going to multiply both sides by 2. So I get y equals 2 times x plus 5 all over x plus 2. I'm going to go ahead and rewrite it as 2x plus 10 all over x plus 2. Now, if we look at this one, we would know that this has a lower degree. Let me get out this sheet. So right here, if the top degree is less than the bottom degree, our vertical asymptote is y equals 0. And if the top degree equals the bottom degree, then we take the coefficients of the higher degree term to figure out what the asymptote. We're going to use this now for this particular problem. So if we take a look at this one, we can see we have a degree here that is greater than the degree in the top. That means y equals 0 is our horizontal asymptote. If we look at this one, we can see that these degrees are the same. So we go 2 over 1, and that would be our new horizontal asymptote. So you can see that this one, because of the horizontal asymptote rule, got bumped up 2. So we can say, yeah, you got 2 units up, and left 2 units comes from, well, right here. That would move it left 2. Because our vertical asymptote, x cannot equal -2, moves the original one from x cannot equal 0 left 2. So the horizontal asymptotes help us and the vertical asymptotes help us. Very similar to the last problem's explanation. So now we're up to letter C. Does this move it left 2 and up 2? And the answer is yes, but here's why. Vertical asymptote, x equals -2. Vertical asymptote, x equals 0. So we see that it's been moved left 2, which works. And then you look at this, we're like, hey, wait a minute. We know that this one has a y equals 0 horizontal asymptote. This one, because the degrees in the top and the bottom are the same, we just take off the coefficients and we say y equals 2. Again, from y equals 0 to y equals 2, up 2, so it matches. Now a little quicker, we see this, the horizontal asymptote would be y equals 6 from y equals 0, so we'd say no, letter D does not work.